China will no longer control EV batteries. Elon Musk has just unveiled the all-new Tesla Model 2 battery for 2026, with a car price of only $10,387 and a lifespan of up to 1.2 million miles. This announcement not only shook the entire industry, but also challenged Asia's entire supply chain. So what makes Tesla's Gen 2 battery powerful enough to break China's dominance in the global battery market? Before we begin, please help us reach 9,500 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What has Elon Musk done to break China's battery monopoly? Recently, Sawyer Merritt, a keen observer of all things Tesla, shared a bold claim from veteran analyst Alex Potter of Piper Sandler on X. According to Potter, Tesla is currently the only automaker truly committed to building a large-scale battery supply chain without relying on China. As usual, Elon Musk didn't stay silent. He replied directly with a message of firm resolve. It is important, albeit extremely hard work, to localize supply chains to mitigate geopolitical risk. This wasn't just a statement of caution, it was a clear declaration of intent. Musk is quietly leading one of the most aggressive efforts in modern history to achieve full battery independence. His goal isn't merely incremental improvement, but a full-scale revolution of the battery supply chain, from raw lithium mining to finished battery cell production, all done within the United States. Instead of continuing to rely on China, which currently dominates the global lithium-ion battery supply, Tesla is pouring billions of dollars into changing course. One of the clearest moves was its $3.6 billion investment to expand the Nevada Gigafactory, now building an in-house lithium refinery and fully integrated cathode production line. Once fully operational, the facility will supply battery materials for over 1 million EVs annually, without using any graphite, cobalt, or nickel sourced from China. That's a rare milestone, especially as most U.S. companies are still scrambling to reduce their dependence on Asia. According to Alex Potter, Tesla is taking on nearly the entire process: refining lithium, producing cathode and anode materials, encoding electrode components, assembling battery cells, and finally installing them into their own cars. No other American automaker can say the same. This level of control is a powerful strategic advantage, particularly when more than 70% of the world's lithium-ion batteries are still produced in China, a country that could disrupt the global supply chain at any moment due to geopolitical tensions. Tesla's strategy goes beyond building factories. It aligns smartly with the shifting political climate in the U.S. Amid growing bipartisan support for reshoring critical industries, Tesla has moved far ahead of its competitors. A major inflection point is expected in 2026, when the proposed Build Beautiful Act could be enacted. This legislation would require EVs and batteries to be fully U.S.-made in order to qualify for the $7,500 federal tax credit. Automakers that fail to localize production will lose a crucial competitive edge. Meanwhile, Tesla's vertically integrated battery system will be ready on day one, putting it among the few companies able to capture the full benefit immediately. The numbers tell a compelling story of transformation. In 2023, Tesla still had to import over 70% of its lithium from China and South America. More than 80% of its anode materials, especially graphite, came from Chinese suppliers, and most cathodes and battery cell assemblies still depended on Chinese infrastructure. But by 2026, that picture will look very different. Lithium will be refined domestically in Nevada, materials encoded and processed in the U.S., cathodes manufactured in Tesla's Texas facility using American or allied resources, and final battery cell assembly completed entirely within the U.S. This sweeping overhaul will give Tesla unmatched advantages in cost, speed, scalability, and quality control. Tesla isn't just an automaker anymore. It's building an entirely new industrial model, an energy superpower that's self-reliant and shielded from foreign interference, supply chain shocks, and geopolitical risks. Meanwhile, the rest of the global auto industry remains heavily reliant on China's battery supply. This reality sends a clear message: whoever controls the battery controls the future of electric transportation. And with Tesla making bold, decisive moves on every front, the real question is whether other automakers can even keep up, especially while still tied to overseas materials and core technologies. If Tesla succeeds, the upcoming Model 2, an affordable EV powered by Tesla's own 4680 Gen 2 cells, will represent far more than just a new car. It will symbolize a new era, an American-made EV built by Americans for the future of American energy independence. Once again, please help us reach 9,500 subscribers. This is important for us to stay motivated. Thank you. Why does Tesla still choose to rely on and place a big bet on the 4680 Gen 2 battery? The 4680 Gen 2 battery isn't just a simple upgrade. It's a complete overhaul of how energy is stored, delivered, and scaled for electric vehicles. While the name 4680 refers to its physical size, 46 millimeters in diameter and 80 millimeters tall, the real revolution lies inside these oversized cylindrical cells, especially in the second-generation version that Tesla is now preparing for mass production. One of the most fundamental shifts in Gen 2 comes from how Tesla redesigned the internal architecture of the cell. By improving the tabless design first introduced in Generation 1, Tesla managed to further reduce internal resistance by an additional 20 to 30%. Traditional lithium-ion batteries rely on tabs, metal connectors that act as gateways for electrons, but they also create thermal hotspots and bottlenecks. The tabless layout distributes current evenly across the electrode's surface, reducing heat buildup, improving power delivery, and enhancing safety. In Generation 2, Tesla has refined this design to support even faster charging and better temperature regulation under load. Another major leap is Tesla's move towards silicon-based anodes instead of traditional graphite. Silicon can store up to 10 times more lithium ions than graphite, drastically boosting energy density. But it also expands significantly during charging, a problem that has haunted battery engineers for years. Tesla overcame this challenge with a custom elastic binder that holds together a nanostructured silicon composite, allowing it to expand and contract without cracking or degrading. This innovation extends the battery's cycle life while delivering 35 to 50% more energy density compared to earlier cells. Tesla also made big strides on the cathode side. The new Gen 2 cells use a high-nickel chemistry that eliminates cobalt entirely, a move that improves specific energy while cutting reliance on ethically problematic and expensive imported minerals. This shift not only raises the performance ceiling, but also aligns with Tesla's aggressive push to localize and clean up its supply chain. With in-house cathode production underway in Texas, Tesla is minimizing both geopolitical risks and environmental impact. These internal improvements pay off in real-world driving. Paired with upcoming models like the Tesla Model 2, Gen 2 cells are expected to enable a real-world range of up to 350 miles on a single charge. But it's not just about range. It's about thermal safety and resilience. Unlike traditional lithium iron phosphate (LFP) cells that use flammable liquid electrolytes, Gen 2 leverages semi-solid or solid-state electrolyte formulations. The result is up to 30% higher thermal tolerance, making it safer under high acceleration, heavy load, or hot weather conditions. Battery longevity has also taken a massive leap. According to internal estimates, Gen 2 cells could last up to 1.2 million miles, roughly 3 to 4 times longer than most gas engines, and double the life of many current EV battery packs. For long-term owners, this significantly reduces the fear of battery degradation and lowers total maintenance costs over the car's lifetime. When it comes to charging performance, the Gen 2 shines again. Thanks to a larger current path, lower resistance, and superior thermal management, these batteries can fast charge from 0 to 80% in just 15 minutes. That's half the time it takes for most EVs under $30,000 and closes the gap with gasoline refueling, making EVs far more convenient for everyday users. The psychological barrier of long charge times, a key concern for hesitant buyers, is starting to fall. But Tesla's innovation doesn't stop at the cell level. The company is ramping up industrial-scale production to meet future demand. The Gigafactory in Nevada is being expanded to churn out more than 100 gigawatt-hours of 4,680 Gen 2 cells annually by 2026, enough to power over 1.3 million EVs per year. In parallel, Tesla is building its own lithium refining plant in Corpus Christi, Texas. Once operational, it will process enough lithium carbonate and hydroxide to support another 1 million EVs annually. By handling lithium refining internally, Tesla aims to slash battery costs by up to 30% while avoiding global price swings and long shipping delays. This vertical integration from lithium refining to cell assembly is what gives Tesla an unbeatable edge. The company isn't just relying on better materials or smarter designs. It's building a full-stack battery ecosystem. Every layer of the Gen 2 battery reflects that philosophy, combining scientific breakthroughs with industrial execution. The result is not just a more powerful battery. It's a strategic weapon in Tesla's EV dominance. The 4680 Gen 2 could very well be the most significant advancement in EV battery tech. With higher energy density, faster charging, longer lifespan, safer chemistry, and full vertical integration, it resets what the industry thought was possible. If you believe Tesla is writing the future of transportation, then the Gen 2 battery is page 1 of that story, and it's already in production. Why is Tesla's Gen 2 battery considered the key factor in making EVs more affordable? The 4680 Gen 2 battery represents a groundbreaking leap for Tesla, offering significantly higher power output, superior durability, and optimized efficiency that outpaces anything currently available in its class. With an estimated energy density increase of 35 to 50%, Tesla can extend driving range without increasing battery size. This single advancement allows upgraded versions of the Model 2 to achieve real-world ranges exceeding 300 miles, a figure previously reserved for EVs priced above $35,000. Today, Tesla is delivering that level of performance in a vehicle starting at just $10,387, giving consumers the chance to save up to $20,000 while still owning a long-range, high-performance electric car. But it's not just about range. The Gen 2 battery also enhances thermal management by up to 30%, significantly reducing the risk of overheating during rapid charging or hard acceleration. This is a critical safety factor and ensures long-term stability of the battery pack. For everyday users, it translates to fewer battery-related incidents and up to 40% savings in long-term maintenance costs. Each Gen 2 cell is designed to last up to 1.2 million miles, roughly equivalent to driving 40 miles a day for over 80 years. This kind of longevity not only provides unmatched value to owners, but also saves up to $12,000 in battery replacement costs over the life of the vehicle. On the charging front, the improved cell design enables charging from 0 to 80% in just 15 minutes, nearly twice as fast as current EVs priced below $30,000. This slashes wait times by over 50%, bringing Tesla closer than ever to a true 5-minute fueling experience, a key milestone in winning over traditional gasoline vehicle buyers. This vertically integrated approach is the foundation of Tesla's breakthrough. By eliminating third-party intermediaries and controlling every stage of the production process, Tesla reduces overall manufacturing costs. It's estimated that this strategy saves $4,000 to $6,000 per vehicle, much of which is directly passed on to consumers through lower sticker prices. This is how Tesla is building a high-performance, long-range EV that remains affordable to the average American, from working-class families to retirees. As Elon Musk once noted, this integrated model gives Tesla lasting advantages in speed, efficiency, and cost. For consumers, this doesn't just mean owning a powerful, long-lasting EV. It's about having access to future-ready transportation at a price lower than many used gasoline cars. The next-generation 4680 Gen 2 cells being produced in Nevada, using lithium refined directly in Texas, symbolize Tesla's quiet revolution, one that moves the U.S. closer to full energy independence. Once installed in the Model 2, this car won't just be another budget EV. It will be the boldest manifestation of Elon Musk's vision to eliminate dependence on Chinese battery supply chains and secure America's technological future. This vehicle is more than just economically viable. It is a declaration of control over the EV supply chain from the ground up. And the real question is whether this could become the first car to break China's global battery dominance. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.